It came from the dark, a silent traveler between the stars. In 2017, our solar system had an unexpected guest, Oumuamua, the first object ever seen from another star system. Our telescopes caught it only as it was leaving, already speeding away. It was a ghost slipping through our cosmic neighborhood, leaving us with more questions than answers. Long and thin, shaped like a cigar or pancake, it tumbled through space in a strange way. Most puzzling of all, it accelerated away from the sun, but had no visible tail like a comet. The scout from the stars vanished back into the interstellar darkness, a mystery unsolved. Our solar system is not an isolated island. Objects from other stars can and do visit us. The frustration was immense. We had the technology to send probes to distant planets, yet this visitor slipped through our fingers. It taught us a valuable lesson. The universe will not wait for us to be ready. Next time, we vowed, we would not let the opportunity slip by. The hunt for interstellar visitors had begun. 2 years later, another arrived. In 2019, Gennady Borisov discovered a new comet, 2I Borisov. Its path was all wrong, another interstellar visitor. But this time, it looked familiar. A classic comet with a glowing coma and tail. Telescopes turned to study it. We found water and carbon monoxide, just like comets from our solar system. Maybe Oumuamua was just an oddity. Now we had 2 data points, one bizarre, one familiar. The universe, it seems, has more imagination than we do. The search for more interstellar visitors intensified. The next visitor would change everything. The game changed in 2025. In the Chilean Andes, the Vera C. Rubin Observatory opened its eyes to the universe. Not just another telescope, but a cosmic sentinel, scanning the entire southern sky every few nights. Its mission, to create the most detailed map of the night sky ever made, and to spot faint, fast-moving objects. In autumn 2025, its automated systems flagged a faint speck of light, moving on an unmistakably interstellar trajectory. The third interstellar object had arrived, 3I Atlas. This time, we saw it early, still far from the sun, on its way in. We had time to observe, analyze, and maybe even act. The discovery of 3I Atlas was a triumph of modern astronomy. Oumuamua was found by chance, Borisov by a dedicated amateur, but 3I Atlas was found by a machine built for this purpose. The Rubin Observatory represents a new strategy: systematic, repeated sky surveys. It can detect things too faint and fast for older surveys. Now, finding interstellar travelers is becoming a regular occurrence. The Rubin Observatory and similar surveys are our early warning system. They give us the crucial head start we need. The discovery of 3I Atlas proved our new approach was working. We were no longer passive observers. We had built a watchtower on the cosmic shore, scanning for incoming ships. The era of waiting was over. The era of discovery had begun. As 3I Atlas drew closer, a new puzzle emerged. It wasn't like Oumuamua or Borisov, it was something in between. Its brightness changed as it rotated, but not dramatically, suggesting a more conventional shape. But as it neared the sun, there was no tail, no outgassing, no coma. It remained a sharp point of light, deeply strange for a supposed comet. If it was icy, the sun should have boiled its surface. If it was bare rock, that was an incredible find. Most puzzling, its trajectory showed a tiny, unexplained acceleration, just like Oumuamua. No visible jets, no obvious cause. Was it venting invisible gas? Or was sunlight pushing a lightweight, thin object? The mystery of Oumuamua was back, but in a new form. 3I Atlas didn't fit our models. A hybrid, a missing link. It forced us to reconsider our assumptions about interstellar objects. The diversity of these wanderers was greater than we imagined. Nature, it seems, is full of surprises. 3I Atlas was a messenger carrying a new riddle from the stars. We had to decipher it before it vanished into the void. When faced with cosmic mysteries, it's tempting to imagine aliens. Could Oumuamua or 3I Atlas be artificial probes? Some scientists have seriously considered it. But science demands extraordinary evidence for extraordinary claims. So far, we have none. The strange acceleration could have natural explanations: exotic ices, porous structures, or sunlight pressure. Nature is often stranger than fiction. The scientific process is cautious. exhaust natural explanations before proposing alien technology. While it's fun to speculate, our job is to follow the evidence. The mystery of 3I Atlas drives new research and forces us to think outside the box. We study it with open minds, searching for any sign of artificial origin. But until we find proof, we must assume it's a natural phenomenon, a strange and wonderful one. The universe is vast and old, full of surprises. The real excitement lies in the patient work of discovery. For Oumuamua, we were too late. For Borisov, we watched from afar. But for 3I Atlas, humanity is ready to give chase. Space agencies have planned for this moment. The European Space Agency's Comet Interceptor mission is designed to wait in space, ready to intercept a target like 3I Atlas. The interceptor is actually 3 probes, able to study the object from multiple angles. One will fly through the area around the object, sampling gas and dust. The others will observe from different vantage points, creating a 3D picture. With 3I Atlas discovered, mission controllers sprang into action. The trajectory was calculated, the window identified, and the command sent. The Comet Interceptor fired its engines, beginning its journey to meet the interstellar visitor. This is a cosmic chase, a race to get a close-up look at a messenger from another star. We are no longer waiting for discoveries to come to us. We are going out to meet them. This mission is proactive, the result of lessons learned from Oumuamua. The data will be revolutionary high-resolution images, direct measurements of composition, and answers to long-standing questions. Is it rock, ice, or something else? Soon, we will know. The chase is on, and the world is watching. For the first time, we are ready. The universe has sent us a challenge, and we have answered. The age of interstellar exploration has begun. The secrets of the stars are within our reach. Why chase these interstellar visitors? Because they are cosmic messengers. They carry clues about their home star systems, geological samples from another world, delivered to our doorstep. Every star with planets is a construction site, flinging material into interstellar space. When one of these objects passes through our solar system, it's a direct sample from another planetary system. Analyzing objects like 3I Atlas lets us ask, is the chemistry of planet formation the same everywhere? If these ingredients are common, the potential for life might not be unique to our solar system. Each new interstellar object is another data point in this grand investigation. Borisov looked familiar. Oumuamua and 3I Atlas looked strange. By building a catalog of these visitors, we can understand the diversity of planetary systems in our galaxy. Are rocky planets common? Are water-rich comets the norm? These messengers hold the answers. They help us piece together the story of how planets, and perhaps life, come to be. Studying these objects up close is like holding a piece of another solar system in our hands. Analyzing isotopes gives us a unique fingerprint of the star system where the object was born. This could let us trace an object like 3I Atlas back to its home region of the galaxy. Imagine pointing to a star and saying, "That's where this rock came from." We could then study that star in detail, connecting the tiny object to its cosmic context. A close-up look could solve the mystery of their strange acceleration. Jets of gas, sunlight pressure, or something new. Exploration is about discovering what we don't know. 3I Atlas is a moving piece of territory from another star. This is more than collecting rocks. It's about understanding our place in the universe. Are we rare, or typical products of cosmic evolution? Each interstellar wanderer is a grain of sand containing clues about another world. By studying these grains, we can begin to see the entire galaxy. It's a profound quest for knowledge. We are at the dawn of a new era in astronomy. For centuries we studied the universe from afar. The arrival of Oumuamua, Borisov, and 3I Atlas changed that. We are entering the age of interstellar archaeology, physically touching relics of other star systems. New telescopes and rapid response missions give us the power to find and reach these objects. 3I Atlas is just the first of many encounters to come. In the coming decades, we'll intercept and study a gallery of interstellar visitors. Each one adds a new chapter to our understanding of the galaxy. This new field will drive technology forward, faster spacecraft, better instruments. Perhaps one day, we'll land on an interstellar object. The chase for 3I Atlas is the first step into this larger world. The sky is now a dynamic place, full of visitors passing through. These objects connect us to the galaxy, reminding us we are part of a vast cosmic ecosystem. For the first time, we are ready to listen to the stories they bring.